Good night again to everyone. So we're going to be making a start now. Now, like I said, we're going to be moving relatively fast. I'm just going to be covering the main points that you need to take note of. So if you're not clear about anything that I mentioned, please ask me whatever question that you might have. If you weren't clear as to anything that I might have said, you're free to tell me to repeat whatever you want to hear once again. So let's start with programming. Now, before we head into programming, before you actually build anything in the real world, you must plan first. So that's why we have this topic of problem solving. So problem solving is our method of basically planning so that we can plan how to create our program. So I'll be going through it basically paragraph by paragraph and indicating to you what are the main points you need to basically remember. Now, the first paragraph says that software is a name given to computer programs that tell or basically instruct the hardware as to how it should work. So that's basically the definition of software. It tells or instructs hardware as to how it should work. Hardware is just the physical components of a computer, the physical things that you can touch, keyboard, mouse, CPU, monitor, and so on. But in order for them to work, something must tell them what to do. When you move that mouse, something must basically say that, look, when the mouse moves to the right, this is what should happen. And that is the purpose of software. Now, software therefore includes computer programs that create system and application software. So those are the two types of software that we have: system software and application software. Each program exists because a problem first existed and a solution was needed to solve that problem. So we're now entering the topic of solving a problem, or basically problem solving. How do we carry out problem solving? So you should first develop an algorithm to solve the problem. So you have some sort of issue. Maybe you want to make a robot to do a particular task. So maybe to deliver products. That's the issue. That's the problem. You want to deliver products faster. You want to deliver food faster. So you might develop some sort of program that would carry out that task faster. So before you actually head into creating the program, you must create an algorithm. Now, what is an algorithm? The definition of an algorithm is that it is a sequence of precise instructions which results in a solution. So an algorithm simply tells you what are the steps. Step 1, step 2, step 3, what you need to do to reach towards a solution. So an algorithm starts from a problem and leads you to a solution. It gives you step by step. And notice it's precise steps, tells you exactly what to do. A simple analogy of this here is, say for instance, you have an issue of being hungry. Now, to solve that is that you want to go and eat. But how do we write an algorithm as to reaching that solution now? From being hungry all the way to having something, being full. So an algorithm is basically going to be something like maybe go to the fridge, take food out of the fridge, take ingredients out of the fridge, and you could even break that down and say, take what ingredients out of the fridge, because you got to be precise, you got to be specific. What you're going to do with the ingredients after you take it out of the fridge. How are you going to cook it? What are you going to do with it exactly? How are you going to prepare the bread? How are you going to put it together? You got to open the bag of the bread. So it's precise steps that leads to a solution. Now, the paragraph continues that if your algorithm is vague and has conflicting logic, you will not get the correct answer. So what is meant here? Conflicting logic. Well, basically, how we are carrying out the steps has to be in a logical manner. So, like say for instance, you can't say put ingredients into bread and then cook ingredients. That is not logical. You have to cook the ingredients first, prepare the ingredients first, and then you can put it into the bread. That's a logical step. So the same thing for programming, same thing for algorithm. The steps are always in a logical manner. We have a cycle called IPOS, and this is the general cycle. This is the general steps that we follow when we are creating an algorithm. We always input or put data into our algorithm, put data into our program. Then we process, or we basically calculate what we would have put into the program, what we would have inputted. And then we output the results of what we would have calculated. And then we store those results if it is necessary. So that is our logical manner of creating an algorithm. Input, processing, output, and then storage. Now, the steps are not, it's a bit flexible, you can say at times, because you don't always necessarily have to input. You could put the values already in the program and just run the program just like that with the value already input into the program. And even some algorithms don't need storage, because you don't always need to store the results after you would have finished any calculation. But other than that, the general process is input, process, output, and storage. That is our logic. That's the paths that we follow. Now, any questions so far? Any queries? Any comments? All right. So, problem solving has two phases. We have the algorithm phase. How do we create an algorithm? How do we get towards an algorithm? Firstly, we have to define a problem. How do you define a problem? You have to basically say, what are the causes and effects of a problem? How does it affect you? How does it affect other persons around you? Now, next you have to propose some solutions. So say for instance, the problem is that I'm hungry. Now, how does that affect me? It makes me weak. How does that affect persons around me? It makes them irritable, or it makes me irritable because I'm annoying them, because I'm constantly nagging that I'm hungry. Now, propose some solutions. What can I do? I can go to a supermarket, buy some food. I can go to my parents, get some food. And we have to evaluate each one of them. Which one is going to be the better solution? Is going by my parents going to be the better solution? Is going to the supermarket the better? How do we evaluate? We basically look at advantages and disadvantages. Going to the supermarket, what's the disadvantage? I have to get money. Going to my parents, what's the advantage? I don't have to get money. It's as simple as that. You look at the advantage and disadvantage, and that can lead to you selecting the most reasonable solution, the one that makes the most sense. Now, after you finish carrying out these 3 steps here, that is when you're going to design an algorithm. That is how you figure out that, look, the solution that I'm going to choose is to go to my parents in order to get food. Now, I need to design an algorithm in order to get to that solution now. So the problem, once again, is that I'm hungry. I chose the solution of going to my parents. Now, how do I design this algorithm? I basically say, go to the washroom, bathe, change clothes, put on new clothes, pack my bag, ensure I have money to go to my parents, leave the house, lock the door, catch a bus, go to my parents, tell them I want food. And it can even be more precise steps in between all of that. But that's basically the idea as to how you write an algorithm. So in your exam, if they ever ask you to write an algorithm, you got to ensure that your steps are precise. And once again, IPOS. If they ask you to create an algorithm to add 2 numbers, you basically have to say that you have to input 2 numbers, and then you basically indicate that you're going to store that. Well, we can come to all of that later, but you have to indicate that you're going to put 2 values into this algorithm, into this program. Then you got to say, what are you going to do with that 2 numbers? So add two numbers, then output the results. So notice that IPOS there. So you put in the two numbers, you add the two numbers, and then you output the result of those two numbers. That's basically just a glimpse there of what an algorithm can look like. Now, testing an algorithm is tested using what is called a trace table, TT. Now, a trace table is basically just a table that documents all the steps that you would have placed into your algorithm. Say, for instance, this was step 1, step 2, step 3. So your trace table basically documents those steps. And you basically say what exactly happens at each step. So that's how you test your algorithm. So that's basically the algorithm phase there. From issue to designing and testing a algorithm. Now, after you're finished designing this algorithm, you test it, you're entering the implementation phase. You now have to convert this algorithm into a programming language. So now we are creating a program. What programming languages do we have? These are just some of the most common ones. Basic, Pascal, C, Visual Basic. We have C++, we have C#, we have Python, we have Java, we have many examples. So you just need to remember the most common ones in the exam. They might ask you which of the following is or is not a programming language. So knowing what they are is going to be beneficial. Note that they might trick you with Basic and Visual Basic. Know that both are programming language. Note how they are spelled. But they're not related to each other. Just know that what I mean they're not related, I mean that they're two different programming language. So the first step of the implementation phase is basically translation. Taking your algorithm, converting it into a program language. Now, after you finish that translation, you have to basically test it, execute it, run the program, see if it is working. Now, after your program is working, you need to maintain it. What is maintenance? You basically try to fix any bugs, any issues that might not be working. If you have any future updates, any added features that you want to, additional features you want to add to this program, all of that is done at this phase here, the implementation phase. Any questions, any comments? All right. So how do you define a problem? How do you explain a problem? I'm just going to summarize all of this here. So basically, you have to just simply say, what do you expect as output from this problem? Do you expect it to be numbers? Do you expect it to be text? Do you expect it to be maybe an image? What do you expect the output to be from this solution? Now, the next step, what do you have to put in to get this particular output? So say, for instance, you want a number output, then obviously you got to put in numbers in order to get a calculation to get numbers as your output. Now, after you're finished figuring out what is your input, what is your output, you have to figure out how are you going to process that in order to get that particular output. How are you going to take this input, calculate it, manipulate it, process it, and convert it into this output? So if you notice, we're back to that same cycle there, IPOS. Now, storage, as I mentioned before, storage is optional. Some programs may not need to store any data. Some may need to store data. So that's basically how you summarize, how you define a problem, how you indicate what has to be done for that solution. Now, an IPO chart. What is an IPO chart? Now, an IPO chart, very important to take note of. It is not a table. It is not a chart. The title is IPO chart, but it's not actually a chart. Like when we say chart, it's not a pie chart. It's not a column graph. It's not a chart or a graph. It's basically a table. So as you can see on the right-hand side here, if I draw in some lines here, we basically have a table. An IPO chart is simply a 3-column table. And all you're doing, as the name implies, IPO, you're matching input, processing, and output. And in this table, you're simply indicating what has to be put into the program as input, how you're going to calculate that input, and what is the expected result from that process, from that calculation. So before you create an algorithm, you would actually create an IPO chart, because the IPO chart gives you a summary as to what you're going to put into the program, how you're going to calculate it, and how you're going to output that result from that process in there. So we have an example over here. Let's look at example 2. So you're given the problem of finding the average temperature by using maximum and minimum temperature readings. You then calculate and output the average temperature. Now, sometimes the statements might tell you exactly what you need to do. If it simply says put in this value, input this value, you already know that those words should indicate input. It means that you're putting it into the program. So we're putting in maximum and minimum temperature into our IPO charts. So notice that's under this input column here. Now we need to calculate the average temperature. Now it's basically simple maths. You need to remember whenever you're doing processing, just ignore everything about IT and just think about simple maths when it comes to your processing. How do we calculate average? Average is simply adding the total and dividing by how much ever different values would have been used in that addition. So we basically use 2 different values, and those 2 values are used here and then divided by 2. So when you have to create your IPO chart, your algorithm, just think of it firstly in as to create a simple formula. Ignore everything else about algorithm, just create it mentally as a formula, and then just simply transpose it now as to how it would look in an actual algorithm. All right, so that there is just a summary as to what is an IPO chart. Any questions in this chapter here before we move on? All right. The next chapter, algorithm design. We're going to be looking at some additional terms. Now, to help the simplification and development of the programming problem, algorithms can be created as pseudocode or flowchart. So, algorithm, a pseudocode or a flowchart is technically not types of algorithm. They're just methods as to how you're going to represent this algorithm. So an algorithm, once again, is a step-by-step instruction required to obtain solution to a problem. It must have a set of rules, it must be explicit, and it must have a clear stopping point. So these are the characteristics as to a good algorithm. It basically must have a clear stopping point that, look, this is the end of it, this is the starting of it, and you must know exactly what a step is doing. You shouldn't have to guess as to what a step is actually saying. Now, it is really used to expand the processing part of the IPO chart. Now, note that a flowchart uses diagrams in order to represent its steps, and a pseudocode uses English statements, or basically just statements, because if it was another language, it would have been French statements, Spanish statements. So it's basically just statements used inside of this pseudocode, English-like statements. Now the algorithm should start with a title. That title is usually indication of a start, but nothing is wrong of just writing the word start or the word begin at the starting point of your algorithm to indicate that is where your algorithm is started from also. But just note, if you're creating an algorithm, it must have a title. And the keyword start and begin indicates that starting also. But title also indicates that start. Now you must use the keyword end to indicate that is the end of an algorithm. End or stop, either one. Now developing a program can be a major undertaking, so good algorithm design is important. It is not always possible to satisfy all the requirements of a good algorithm. Some problems may be complex, So these are some general guidelines as to how you create an algorithm. An algorithm must be correct. So these can actually be questions in your exam. An algorithm must be correct in that it must accept all forms of input, even input that are incorrect, even input that does not make sense. Why are we saying this here? So say for instance, our algorithm is a calculator. Now we know a calculator only calculates numbers. Now an incorrect input is going to be a letter, but we're saying that it should accept that letter. Why? Not because letters are used in maths, but simply because we need to indicate to the person, give them a meaningful response that, look, the letter that maybe you would have pressed, that you would have entered, is a wrong response. It is an input that we will not accept, that we will not calculate. So all algorithms, all programs must have this correction, as you can say, in that whatever the person inputs, whatever the person types in, it must give them a meaningful response. Either it works as normal, or it indicates to the person that, look, what you would have typed, what you would have entered is not correct. Please try again. Please type what is correct. That's simple. An algorithm must be simple in that each step of your algorithm is a logical step. You don't combine multiple actions into one step. So we don't combine input and processing into one step. We separate them, we break them down. Even if we have multiple inputs, we separate each into its own individual steps. If we have 10 input, 10 different input, that means we have 10 different steps. So each logical step is basically one logical action. An algorithm must be clear, meaning that anyone should be able to read it and understand it. If you write this algorithm, obviously you're going to be writing one in your exam. Whoever is marking your paper should be able to read it with no problem. That's how it should be written. And that's why we say an algorithm is written in English statements. So you can simply say input two numbers. And that's an indication that you're putting two numbers into a program. And you can then further break that down. Input one number into what, input one number into another number into what, and so on. So you're clear as to what is actually happening. An algorithm must be precise. The algorithm should present the solution steps precisely and concisely without low-level code. Basically, once again, we're just using English words. So we're not using anything too technical, like we're not using binary language or anything, any form of programming language or so on. Just English words, English, like if you're writing a sentence. The algorithm must be easy to implement, meaning that it should be easy to just translate. You take one line and you just do a translation. It must be efficient. Efficiency can deal with how much steps you have. The smaller amount of steps that you have can lead to efficiency. It means that's less reading, less action being carried out, less memory being taken up. All of that is part of efficiency. Now that you've been introduced to algorithms, familiar with terminologies, So we should be clear as to what is a pseudocode, what is a flowchart. All right. So what is a variable? What is a constant? Now, as we've been saying, we need to put values into our algorithm. We need to put values into our program. So, what is going to store our values? What is going to store our input? Well, that is where the variables and the constants come into play. Think of the variable and constants as containers. Think of them as bowls. They're basically going to be used to store our values. Now, a variable and a constant, they work differently. Now, the technical definition is that a variable or constant is an area in memory. What memory? The RAM. It is an area in the memory or the RAM of the computer or the main memory. This is another important point. Main memory. Those three terms, you can see them interchangeably in your exam. Memory, RAM, main memory, they refer to the same thing. They refer to the same type of memory. A temporary form of memory that your computer uses. That's basically when you open Task Manager, this memory here that you're seeing, notice the same word there, memory. When you check performance, this same RAM memory that you have here, that's what it's referring to. So those three terms, they can use them interchangeably. Now, how does a variable or constant work? The technical aspect is that it creates a space in memory so that it can store whatever you would have input into the program. Now, you can store both text and numbers. Now, what is the difference? Now, note a constant is a type of variable. A constant is a type of variable. So, a variable, as the name implies, the value changes. The value varies. That's why it's called a variable. It varies. So, whatever you put in a variable, it can change down the line in a program. A constant, as the name implies, it is constant. It remains the same. So, a constant is going to keep that value throughout the program. So if you set the value to 10, it's going to stay at 10 and nothing can change that value. So why do we use constants? There are some cases where we need a fixed value and that value is going to remain the same throughout the program and there is no reason to change it. For example, pi. Pi is always 3.14. So if we need to use that, we can use it as a constant so that we can keep it as that value. VAT. Certain countries, businesses, they use a standard percentage of VAT. They use a standard percentage of discount. That value rarely changes, especially for discount. That might vary from time to time, but VAT mostly does not change. That's going to be a fixed value. Once again, a constant can be used in that case. So anytime a value needs to be kept the same, we use what is called a constant. A variable is when we want to change the values, when we want to accept different input. Like for instance, the calculator. For the calculator, we can't use a constant because we need to calculate different numbers. So we need to be able to type in different numbers. Now, the values in a variable can change, as I said, throughout the algorithm, throughout the program. Examples of variables, names are number and total. All right, so as I said, a variable is basically a container. Think of it as a bowl. Now, each bowl, each container has a type. You need to remember what are the types that we have. So we have 5 major types of variables. We have the integer. The integer is basically referring to whole numbers, positive or negative whole numbers. Now the real, which basically means these two are referring to numbers, integer and real. But the only difference is that real is going to give you fractional numbers, numbers with decimal places. So both can be used for numbers, but one is without decimal place, one is with the decimal place. Character and string, those two are kind of related to each other. Character is used to store a single character. So the letter G, the letter B, or maybe some form of symbol. But when you want to store a collection of characters, that is where we have to use the variable type of string. So a string, as the name implies, a string. So think of it as connecting multiple characters. So you're allowed to type multiple characters, even a single character. So don't think you cannot type a single character inside of a string. That is allowed. Boolean, the data type Boolean is when you have a variable that can only store two values. For example, true or false, yes or no, male or female. When there is a situation where you only have two values, the data type of Boolean is what is going to be the most useful. Now, why are we talking about this here? Well, when you're setting variable types, when you're setting the data type, you need to indicate what is the most appropriate. Those are going to be questions in your exam. What are the most appropriate data type for this particular data? So if we need to store a sentence, a string is going to be the most appropriate. If we just need to store maybe a grade, and when I say a grade, maybe a letter grading, A, B, C, and so on, then character might be the most useful. But if it's the case we got to add symbols, like for example, A plus and B plus and so on, then obviously character is not going to work. We need to use string. For the numbers, if we know that we need to store a number, like for example, maybe the VAT once again, and we need to store it in its decimal form, 0.14, then we should know we have to use the real data type and not the integer. Now, all variables must have a name. We must give them meaningful names, names that we can understand. So basically, when you look at the name of a variable, it should tell you exactly what is being stored into that variable. Like for instance, you would not give a variable the name. Whose name is it referring to? The name of a person, the name of a pet? We don't know. So if we say first name, then we know which version of the name that we're referring to. But then we might not know whose name are we referring to. So we might add customer first name. So we need to think about those things when we are creating variable names. It must indicate what is being stored into that variable. For instance, we can name a variable VAT. That's clear as to what that is. We can name a variable total. That's clear, it's for total. But we can also indicate what kind of total. Maybe VAT total, and so on. So ensure all variable names are clear. All right, good night to everyone. Good night. Can you guys see my screen?
Yes, sir.
All right, great. So remember once again, like in the previous session where we got disrupted from blackout, this session will go fast. We have a lot of content that we're trying to cover. Mostly going to be giving you the main points that you need to remember. Remember once again, this session is for you. So if you're not clear in anything, if went too fast on something and you want me to repeat, you're free to stop me at any time and tell me to repeat. If you have any questions at any point in time, you're free to ask whatever question you have at any point in time. The class we had the other day, we basically started with this chapter here. So I'll post that recording later. I'm going to merge it with this recording of tonight, and so that it can just be one recording. We basically looked at what is problem solving, what is the algorithm phase, the implementation phase, what is the IPO chart. We looked at what is a variable, what is a constant, how to effectively design an algorithm, and at statement we got disconnected. So we're going to start with statements tonight. What is a statement? What is a keyword? Well, a statement or a keyword, it is basically a description of the processing that can include an action or condition. So in simple terms, a statement is basically indicating what is happening, what action is being carried out. So instructions within the statement are called keywords. So some example of keywords are going to be input, read, output, display, print, write, and so on. They basically tell you what is happening. Because an algorithm, you can simply say in an algorithm, you can write it this way, nothing is wrong. Put the number 1 and the number 2 in the variables number 1 and number 2. You can write an algorithm like that. But when it comes to pseudocode, we have a bit more of a structure that we follow. We have some rules or like some guidelines that we would follow. And those statements, those keywords are a part of it. So this one line that we have there can be summarized into input number 1. That's simple. So that simple phrase there, input number 1, that keyword there, input, is simply indicating what is the action that we need to put something into this variable here. So that's the purpose of statements and keywords, to tell you what action is being carried out. We have a type of statement called a conditional statement. So a condition is being looked at. Now, conditional statement allow decisions to be made. So anytime you think of condition, think of a decision that is being carried out. Think of it this way. You walk up to a crossroad and you have to make a decision. Do you go straight? Do you turn right? Do you turn left? What is the condition now? The condition is going to be sort of situation. Maybe you want to go to school. School is this way. That is the condition. You want to go to school. So you go straight. Maybe you don't want to go to school, so you turn left. There's the condition. So that's basically how conditional statements work. You have this situation, you have this condition, and you basically take different paths. You make certain decisions. So this includes deciding which statements are to be executed or basically carried out. For example, you might want a set of statements to execute only if a condition is met. So the if statement is basically that conditional statement. So basically, like if you say, if age is greater than 10, then you carry out these particular statements. If age is greater than 20, then you carry out these particular statements. So the conditional statement is to basically running certain parts of your program, basically taking different paths in your program. Another set of statements are your loops. Your loops are basically for repeating certain statements. When you write an algorithm, when you're writing your steps that are going to be carried out, you do not duplicate them. Like if you need to run something 10 times, you do not copy and paste it 10 times. You surround it with what is called a loop. And that loop is what is going to repeat that statement. So loops are useful for repeating parts of a program. That is, they will repeatedly execute a section of a program until the condition is satisfied. So before you even go and repeat this part of the program, there must be a condition. So it must be saying that, look, this is the situation, and only then you should repeat this part of the program. Just like the conditional statement. Now, in order to exit from a loop, you must have a method for checking to see if you have completed a task. Once the loop terminates, control is returned to the first statement after the block of statements in the loop. What this is basically saying in summary, what you need to remember is that a program works in a sequential manner, meaning one after each other. It runs step number 1, then 2, then 3, then 4, then 5, then 6, and so on. It goes in that sequential manner. That is how a program works. Now, you can simply say, repeat or loop steps 4 and 5, maybe for 10 times. Now, when that loop finishes, that repeating of that part, where does it go? What does it do? It still continues the sequence. It was looping 4 and 5, and the next step is going to be 6. All of this can be questions in your exam. If a certain part of the program was looped for how many times, where does it continue next? What is the next step? The next step is basically the next logical step. Now, we were talking about that if conditional statement. So like say, for instance, at step 1, we had if. We could say if maybe age is greater than 10, then jump to step 4. If age is greater than 20, then maybe jump to step 6. So if you notice, you're taking different paths. You're going to different locations, or you're going to different statements in your program. Any questions so far? All right.
No, sir.
Next, we have a term called subroutines. Now, subroutines has a variety of terms that basically mean the same thing. Subroutine, functions, modules, procedures. So for big programs, it is easier to work on small sections by separating the algorithm into individual sections. So like if you got to create the whole Microsoft Office, you don't just put one person to do everything. You break it up into parts. So like, for instance, you might say somebody's going to work on Word, somebody's going to work on database, somebody's going to work to build Excel, and so on. And even still, this you can further subdivide. Maybe you might say 10 different person is going to work on different parts of Microsoft Word. Another 20 is going to work on database. So subroutining, functions, module, procedures, they all basically mean you take a large program and you break it into parts. Each part now is now assigned to a person to build the code for that particular program. So a subroutine is a named section of a program that can be repeatedly called on. So this is another reason why we do subroutine, so that we can repeatedly call this section or use this section. So remember, once again, I said before, we do not duplicate. We loop. We repeat what was already created. So here, with a subroutine, say for instance, if we have subroutine 1, subroutine 2, subroutine 3, here after 3 we can repeat 1. We can just say use back all of the codes that are in subroutine 1, and then continue with 4, then continue with 5. And then we say, look, we want you to use back 3 once again. So we are basically micromanaging, you can say. Every person is carrying out a particular task. So you can repeatedly call on to perform a given set of instruction by other parts of the program. Now, sometimes it returns information to another part of the program, such as accepting a number between 1 and 5, and then return the corresponding day of the week. Other subroutines might carry out instructions such as printing, headings of invoices, or so on. Basically, different subroutines carry out different tasks in the program. Some might print something, some might output a result, some might do a calculation, some might be for accepting input, various tasks. Using subroutine saves writing the same code several times in the program. So that's the benefit of subroutine. You don't need to write the same thing over and over. You can just basically use back that old code, that old statement. This method of focusing on the program's main goal and then separating the program into manageable components is called divide and conquer, or top-down. So divide and conquer, you break it up into parts, you work on those individual parts. And then, when all those programmers finish with their individual parts, they merge it together and test to see all if it's working to accomplish its goal. The individual routines can be tested in isolation to check that they correctly perform their function. So each subroutine, each person is responsible for ensuring that their part of the subroutine is working. It's not when they're ready to merge everything together, they can say that, look, the person that was working on Word, he didn't do his part correctly. It's not like a group assignment where you can throw the blame on the person and say they didn't do the part properly. Well, it actually is that way. You can actually blame them because they are the ones responsible. So if, like say for instance, we divided Microsoft Office, we say 10 persons is doing Word, 20 persons is doing database, 30 persons doing Excel. If we combine all of this together and Word is not working, all the blame goes to everybody that was working on Word because they were supposed to test that by itself, to ensure it's working by itself, so that when it goes to merge together, it will work as it's supposed to. So each person is responsible for their own subroutine. Any questions or comments? All right, so
Sir, the subroutine.
go ahead.
Yeah, sir, I'm confused as to what exactly it is because at first I thought I heard you say that it's basically just a way in which you can avoid having to type out the same thing over and over, like bring a piece down and put it in another. But then like later on I heard you say that it's splitting up the program into different parts.
Which in both is true. So if you split the program into parts, let me erase all of this here. If you split the program into parts, so we have a large, so say for instance, this square here is the program. So say for instance, even if we divide this into parts, this here is one part, this here is not a part. And we're gonna see that this here has step 1, step 2, step 3. This one has 4, 5, 6. This one has 7 and 8. And so similarly, this is one large program, and it's basically 3 parts. 1 part, 2 part, 3 parts. Now we can say that you, Akila, you're responsible for this one section at the top here. Amina is responsible for this section 2. Christopher is responsible for this section 3 here. So each of you are responsible for your individual part. Each of you need to ensure it is working. So when you combine it together, it's going to be one large working program. But going back to one thing that you said is that if we want to like use your part here in isolation, we can. So we can take this part here and say like at the end here at step 9, go back and use from your part to the top here. So instead of like copy and pasting and putting it at the bottom here and duplicating, we can say use back this this section of the program and then continue logically downwards. Did that answer the question?
Yes, sir. Thank you.
All right. Any other questions from anyone? So in simple words, subroutining is basically taking the program, one large program, breaking it up into parts. And each individual part, one person is going to work on each part, and each part can be used by itself in isolation. So I could technically at the end here put step 1 again, and then continue with step 2 and step 3 and so on. All of that is possible. All right, because remember by itself it's a working program, but just a smaller version of that larger program. All right, pseudocode. So the previous chapter, the same chapter here, we said basically that an algorithm is your step-by-step process. What you're going to do from going from a problem to a solution. So what are you going to do step by step? Now, a flowchart and a pseudocode are methods of representing that algorithm, are methods of creating this algorithm. They're not really types of algorithm, they're just methods of representing this algorithm. So it's a bit technical, but an algorithm, like I was typing here, An algorithm is more of this first line. You're in an algorithm, you're more allowed to just freely type, freely write in layman's words what's actually going to happen. Like put the number one in the variable number one, put the number two in the variable number two. That's technically an algorithm. It's more in like an everyday kind of speech kind of thing. But a pseudocode has a bit of a more of a structure. It has a bit of some rules that you must follow. That's where the keywords come into play. So like you see here in this example, we're gonna have a bit more of a structure. We're using keywords such as input to indicate that we're putting something in the program. We're using the keyword output to indicate we're taking something out of the program. So, but some persons in the exam, it might be used interchangeably, algorithm, pseudocode, but just know that both of them, they're going to be using English words. That's the main thing to remember. Whereas the flowchart, once you see symbols, once you see shapes, that is the flowchart. But just remember, the purpose of all of them is to indicate the step-by-step instruction. All right, so pseudocode, remember, it is not a programming language. It is not a programming code. It's not what you use to build a program. It's basically a blueprint. Just like how when you go and build a house, you have to have a blueprint. The blueprint for a program is called a pseudocode or a flowchart or an algorithm. So it's not a programming code, but it uses English type words and phrases that are clear enough to be easily converted into the program. So that is why we write it in English words, so that anyone can be able to look at it and convert it into any program, not just a specific programming language, not just Python, not just Java, any language. That's the purpose of pseudocode. So it uses the same statements, keywords, variables, conditional statements, and loops described in the previous section to create the instructions for a solution to a programming problem. Pseudocode can also be developed from an IPO chart to specify what data must be input and processed. So we have an example here of an IPO chart. So remember, IPO chart is a table, 3-column table. First column, what is going to be input into the program. Third column, what is going to be calculated, what is going to be processed. And second, not third, I think it does say third. And the final column, the third column, output, what is going to be the result from the processing. Those are the 3 columns for an IPO chart. And these same values here are technically what you put into the pseudocode. So we would normally say that the pseudocode is that you're expanding on this table here. All right, so we're not going to go through all of that. Now, important to note, ensure that if you're going to, your exam asks you to design a pseudocode algorithm, it must have that keyword end or stop to indicate that's where it's ending. And usually the title is what will indicate start, but nothing is wrong with putting the word start or the word begin. So start, begin, title, all of those to indicate the start of the algorithm. End and stop is to indicate the end. It must have those 2 points. Let's look at an example of a pseudocode. So notice here we have a title indicating the start. Input number 1, this is indicating we're putting a value into the variable number 1. We're putting a value in the variable number 2 and number 3. This line here, we are adding the 3 numbers together, and then we output in the result. And notice end of pseudocode. Let me look at the last example. I think that one is a bit more, yeah. So this is a bit more as to how you might actually design yours if you're going to design it in the exam. So you have a title. The title usually starts with the word pseudocode. Pseudocode colon, and then you put an actual title. The title is going to describe what the pseudocode is going to be doing. And then like right after here, if you want to put the word begin and or start, that's up to you, that's fine. But I recommend you do it just in case CSEC is a bit iffy about the start and the begin and the title. So nothing's wrong with us playing it safe. All right, but here we have the keyword read. Remember our keywords. our keywords. Input and read, those are our two keywords to indicate that we are putting data into the program. We only have two keywords to indicate we are putting data into the program. That is input and read. The other four, output, display, print, and write, are for output. So we have two keywords for input, four keywords for output. If you see any one of these four, they mean the same thing. Input and read, it means input. These four here, output, display, print, write, they mean output. So notice here they're using the keyword read, indicating that we are putting a value in the variable number 1, the variable number 2, and the variable number 3. Now, when we do a calculation, when we do a process, we usually write it in this manner. The formula is on the right-hand side, and where we're going to store it is on the left-hand side. That's how we write it. So we're going to add number 1, number 2, number 3, and then store it into the variable called result. So anytime we need to calculate anything, this is our general structure. Formula on the right hand, whatever addition, multiplication, whatever operation on the right hand, you must store that result somewhere. You have to store that calculation somewhere. And it's going to go equal sign and the variable on the left hand side. That is the general structure. The last line here, we have print. Once again, this is a keyword to indicate that something is coming out to the computer. So you're outputting whatever is in this variable called result. So remember, we always use variables to store our values. Whether we input in, whether we calculate in, variables are used to store everything. All right, so any questions so far? Any comments? Remember, for those that join late, at any point in time you have any questions, feel free to stop me and ask them. If you want me to repeat anything, stop me at any time and tell me to repeat. All right, sequential statements. Now, sequential statement, as the word sequential means, one after each other. So this is basically how all programs go. Step 2, step 3, it goes in a sequential manner. The codes are executed one after each other. All right, so let's just run through these examples here so that if you're going to be asked to create one in the exam, maybe you might get an idea. Once again, you have a title. Here you're going to input a value into max temperature. You're going to input a value into minimum temperature. Those are the two variables there. On the right hand, remember that's our formula, that's our calculation, brackets. Basically, when you create your formula, everything that you might have learned in maths, BODMAS, remember that applies here also. So brackets first, this addition here is going to be carried out, and then it's going to be divided by 2. And then that is going to be stored on the left-hand side here. And then we're going to output whatever is inside of this variable here. So that's that algorithm there. Good. So that's sequential statements. Basically, the statements going one after each other, one step after each other. Now, conditional branching is basically conditional statements. We have two of them. We have if-then and we have if-then-else. Those are our two conditional statements. Note that the then is always a representation of if the condition is true, and else is always a representation as to if the condition is false. So if is basically asking the condition. Asking, think of it, if you don't want to say condition, say question. That's how I always say it. If is asking the question. If it is greater than 20. If it is less than 20. It's basically a question. And all questions have two answers. It's either true or it's false. So the then representing that true, the else representing that false. So in an if-then statement, notice there is no else. That simply means it is not considering the false. It is only checking to see if it is true And if it is true, it's going to carry out or it's going to work only if it is true. If it is false, it will just continue to the next step. It will not do anything else or just end the program. So let's look at an actual example. So we have an example here. We have a title. We're going to input 3 numbers. Say, for instance, we're going to input 10, 10, and 10. Now, the next step, we're going to add those 3 numbers together. Adding 10, 10, 10 together is going to give us 30. Now, the question is, if total, which is 30, is it greater than 50? Is that true or false? The answer, false. Now, since the question is false, what are we supposed to do with this next line? Remember, sequential. We have to go one step after each other. So, what do we do with this next step? We are supposed to ignore it. Why? Because the answer is false. That's simple. So, because the answer is false, we ignore this true here. And then we continue with the next sequential or logical step, end if. End if is a statement to indicate the end of that if statement. So, basically how you see me writing here on the algorithm, please try to practice that or do that in your exam also so that you can know what variable holds what value. And that way you'll be able to trace the algorithm effectively. You can draw lines like this here, that this is the starting of the if and this is the ending of the if, so that you can know what part is looping, what part is the starting point, the ending point, and so on. Especially when we get to loop, that's going to be useful. Any questions so far? So this is the general structure of an if-then statement. One thing to note, the if is always checking to see if it is true. Whether it's if-then, whether it's if-then else, is always checking to see if it's true. So that's why the then is here and not the else. So if it is true, it's basically just going to run that. Let's look at another example. So pseudocode title at the top there, we're going to input the age. Now we're going to input the age of 8. So the question is 8. So when you're asking the question, you could replace if with the word is, and that will be able to help you as you go through it. You can say, is 8 less than 13, true or false? And the answer is going to be true, because 8 is less than 13. Now the then keyword is only carried out, the next logical step is that then keyword, and it is only carried out if the condition is true. So that means we have to go on to this next step, which is to output student is not a teenager. Now, if it was not true and it was false, if the condition was false, say for instance the age was 20, then we were to ignore this step here because the condition was false. Then we go to end if and we end the program. We're not going to go through that. We should have a general understanding as to what is if. Where is if then? Okay, so if then else. So that's the if then. Remember, the if then only checks for true. Now we have the if then else. This here is checking for true and false. So let's look at an example. So title, we're going to read 3 numbers. So let me put in 3 numbers once again, 10, 10, and 10. So we're going to get 30 once again. Step number 3, we're going to add those 3 numbers together. We get 30. Step number 4, we're going to ask the question, is total greater than 50? Is 30 greater than 50? That is false. So what are we supposed to do? Remember, we still have to go sequential. So this then step, are we supposed to carry it out? No, because the condition is false. So we have to ignore it. And we move on to the next logical step, the else. And then we print this here. So remember, we're doing a combination of sequential. We're always going sequential. But the condition statement is going to take different steps, allow you to jump to different steps in your program. Let's look at another one here. Title, we're going to input this year. This year is 2023. Birth year, say 2000. 2023 minus birth year, that's going to give us an age of 23. Is age less than 13? Is 23 less than 13? Answer is false. So what do we do with the then once again? We ignore it, and then we output the else. Any questions or comments? Good. Once again, this is the general structure. The if, checking that condition, checking that question, checking to see if it is true. The then is going to carry out the true statements. The then is for the true statements, and the else is for the false statements. So if the condition is false, everything that is after the else is going to be carried out. If it is true, everything from then to whatever is before the else is going to be carried out. All right, if no questions on all of that, we have another statement called the nested condition. Now, this is where you can combine multiple if statements to give you a variety of paths in your program. So, the same example here. So, it's the same process. You just got to remember the same structure of the if statement, and you're basically just repeating that structure. Once you understand the original structure, it's just putting one if inside of another if. So let's look at this one here. So you input a mark, and the mark is going to be 40. Now, if mark is greater than equal to 40, so we got to ask that question. Is 40 greater than equal to 80? It's going to be false. It's not greater. So we have to ignore that then, because all of this here is under this then here. This indentation here is an indication that is a part of this then statement. That is why we indent. So it's all under this true statement, the then, so we have to ignore it, and we go to this false here. Else, because remember the else is if it is false. But here, it's technically we're starting another if you notice here. So else, and we start in another if. We run in another condition. If mark is greater than 70. So is 40 greater than 70? False once again. So we got to look for the same then and else statements. Now if you notice, there is no other else, but our condition is false. So once again, because it is false, we have to ignore the true. And because of sequential statements, we continue as normal. So we come out back on the main steps, and we output, please await the end of term report. So a nested if, a nested condition is basically putting an if statement inside of another if statement. You just got to understand the structure of it by itself, and if you place it in another, it basically works in the same way. Any questions or comments?
No, sir.
All right, loops. Now a loop basically for repeating certain parts of your program. Now a loop basically has four things that make up all loops. Now a loop is going to have a variable that you're going to use to give it a starting value. So basically you're going to say, or basically that loop is like to monitor the loop to determine whether you should go into the loop, whether you should come out of the loop, or so on. So we usually name that loop count. Most times we name it count. It could be any other name, but we usually name it count because that's basically what we're doing. We're counting how many times the loop has been repeated. And by knowing how many times it has been repeated, we can determine, look, should I stay in the loop or should I exit? So a loop has a variable to monitor or to know whether to enter or exit that loop. You're going to have a test to test that loop, test that variable to know whether you should exit or enter that loop. You're going to have a body, which is what you're going to be repeating, and you're going to have an update to that variable. So that variable must be updated every time you run the loop. So that's how we can know the loop run for 1 time, 2 time, 3 time, 4 time, and so on. Those are the 4 parts of a loop. The variable, testing of the variable, the body that will actually be repeated, and an update to that variable. We have two types of loops. We have indefinite loops and definite loops. Indefinite is when you do not know how many times the loop should run for. If it should run for 1 time, if it should run for 10, 20, 1,000. Once you do not know, you use what is called the indefinite loop. The two types of indefinite loop are the while and the repeat loop. The definite loop is when you do know how many times it should run for. If you want it to run exactly for 10 times, you want it to run exactly for 50 times, you use the for loop. Now, this is the most technical part. Remembering the difference between the while and the repeat loop. This usually comes in the exam. There's four key difference. There's a certain part of this textbook that actually summarizes it. I think this is this part here. So there's four main things you need to remember for these two loops here. The while loop, it has the test. Remember, it has to test that variable. And where is that test? At the beginning. The repeat loop, the test is at the end of that loop. That's the first difference. So the while loop has a test at the beginning. The repeat loop has a test at the end. The other difference is the statement, the body. So let me just draw it up quickly. So let's see. Why do I still have that up? All right, so while, W for while, R for repeat. So while has the test at the beginning, so T for test. The repeat has the test at the end. While has the test at the beginning. That's one difference there. Where's the body? So the body is basically after the test for the while, and the body is before the test for the repeat. That's the second difference there. They can ask you that question. Where is the body or where is the statements? Body or statements, either one. How many times can the loop run for? That's the other difference. So the while loop has the possibility of never running because the test is at the beginning. So I'm going to put 0 here. It has the possibility of never running because the test is at the beginning. Whereas the repeat loop is guaranteed of running at least 1 time. It's guaranteed of running at least 1. That's another difference there. That's 3 difference. So the test, where is the test? That's 1 difference. Where is the body or statement? That's another difference. How many times the loop could run for? The while loop has the possibility of never running, 0 time. The repeat loop is guaranteed of running at least once. I always forget what's the 4th one. Anybody remembers the 4th one? As we go through, I might remember it eventually. Any questions, comments? Where are we? Good. So we're talking about the difference there. The while loop exists. Oh, whether the other difference is when does it enter and when does it leave that loop? That's the other difference. So the while loop is going to repeat if it is true and is going to exit if it is false. So where's my colors? So the tests, tests must be true in order to enter, and to exit, It has to be false. And the repeat is basically the opposite. True to exit. True to exit. And false to basically enter or repeat the loop. So that there is the 4 differences there. So let me just repeat them. The while loop, the test is at the beginning. The repeat loop, the test is at the end. That's one difference. Where is the body? The while loop has the body after the test. The repeat loop has the body before the test. Third difference, how many times can the loop run for? The while loop has the possibility of never running, 0 time. The repeat loop has a possibility of running for at least 1 time, guaranteed of running at least once. And the final difference is how do you enter, how do you exit? The while loop, if the test is true, you enter. If the test is false, you exit. The repeat loop, if the test is true, you exit. And if the test is false, you repeat the loop. Those are the 4 differences there. Any questions? All right. No, I do not want to open Paint. All right, so let's continue. Good. So as I said, the general form of the while loop, while condition is true, is going to enter that loop. End while is a statement that is used to basically, or keyword, to indicate the end of that loop. Just like how you have end if. Let's look at an example. So we have 3 variables at the top here. This here is called initializing. So I am giving that variable total a value of 0, giving it a starting value. That's called initializing. So this is the initializing stage here. Next step, output a mark, output enter a mark. This is called prompting because you're telling the person what to do. Next, we input. So I'm going to put in 20. Now, while, what we can do, we can draw a line once again to indicate this is the starting of the while, this is the ending of the while. So while mark, so it's the same question here once again. So we can ask it in a question format to get that answer, whether it's true or false. So while mark is not equal to -1. So we ask it in a question format. Is mark not equal to -1? Is 20 not equal to -1? What is that? True or false? Not equal to. That is true. So 20 is not equal to -1. So since it is true, we have to enter the loop. So we enter the loop and we have a variable of total on the right hand. So that's going to be 0 because remember we initialized the top here with 0. Mark, we gave that a value of 20. So 0 plus 20 is going to be 20 now getting stored into total. Count, notice here, this is the update for that variable that's going to be counting the loop. So this is how we normally do it. Count plus 1. So 0, because remember at the top here we initialize with 0. So 0 plus 1 is going to be stored over here. And then we output, enter a mark. So now I'm going to enter 40. And we're going to input that mark. But remember, this is a loop, so we have to repeat. Now, notice why I'm writing on the screen here once again, why I'm writing next to the variable. Because when I go back to the top here, this is what you have to do. 40 is going to be at the top here now. So now we need to ask back a question because we need to remember what are the old values. So the question now is 40 not equal to a -1? Answer is still true. Now we have to go through the same steps. Now, total, we're not using this initialized value because remember we're now at this step here. We're no longer starting from that initializing. We're now from this stage here. So total is now 20. So it's now 20 here. So it's now 20 plus the mark, which I just entered. which is going to be 40. So it's now 20 plus 40. And that's going to give me a total of 60. 20 plus 40 is going to give me 60. So that's why you need to ensure you write next to your variable so that you can know what value they have, so that when you do an algorithm that is looping, you can know what value it was storing from the previous loop. Now the next step, count as a value of 1. So I need to take away that 0 here, put 1 here. So now it's going to be 1 plus 1. So notice how it's updating, because now I'm going to get 2, which is going to indicate that this is the second time this loop is running for. And then we output once again, enter a mark. Now I'm going to enter -1. So that's just, so that was example how that loop was working. So enter -1. Instead of 4 here, it's now going to be -1. So the question is -1 not equal to -1? That is false. It's not equal. Because remember, -1 is equal to -1. So it's not equal, that's false. So what do we do when a while loop is false? We exit. When a while loop is false, we exit. So everything in here we have to ignore. And we go to the bottom here. We go to the next sequential step. We say total. What's the value of total? 60. What's the value of count? 2. 60 divided by 2 is going to give us 30. That is stored in average. And we display average. And that's how we get that sequential statement. That's how we get that loop to work. Any questions? All right. So we're going to move on to the repeat loop. We already looked at the difference. Remember the repeat loop? The test is all the way at the bottom. So you can walk through into the loop, run the loop. But if you want to repeat it, it must be false. If it's true, you exit. So let's look at an example. Let's look at this one here. So title at the top here. Can you repeat one? Which one? Repeat what? The while. Go over this entire thing here. Okay. So remember the while loop? A loop is used for repeating something. The while loop works by if the test is true, it's going to repeat. If the test is false, it's going to exit. So that's what we have to look for. So while mark is not equal to -1. So we're going to input a mark. We're at this step here. We're going to input a mark of 60. So we're going to ask the question, because remember it's a condition. We have to check to see if it is true or if it is false. So we ask it in a question format. Is 60 not equal to -1? That there is true. 60 is not equal to -1. So what do we do when the while condition is true? We enter the loop. Once it is true, we enter the loop. So we carry out these steps here. We carry out this step, we do our calculation. We carry out this step, do our calculation, and we continue. At here now, it says enter another mark. So maybe we enter 40, and it basically goes back to the top here and does the same thing. So it goes back to the top. If we enter 40, it goes back to the top. Is 40 not equal to -1? Once again, it was true, and we basically continue here. And then until it is actually false, say for instance, we do enter -1. This one is a bit tricky because of the -1. It's a bit technical because we use a not equal. Maybe that's what's throwing you off. Let me show you another example. So age. Age is equal, this one is initialized age to 15. So while age is less than 20, we have our condition here. is age, which is 15, is it less than 20? True. So 15 is less than 20. So if the while is true, we have to enter the loop. So we're going to output, you are a teenager, and we update age plus 1. So that's going to be 15 plus 1. That's going to be 16. So we have to go back to the top. 16 is here now. Is 16 less than 20? True once again. So you output, sequential, output you are a teenager. This here now is going to be 16 plus 1, which now is going to be 17. And then we go back to the top here again. Is 17 less than 20? True. And we keep repeating like that over and over until, say we reach 19. Is 19 less than 20? True. Output, you are a teenager, so it's going to be 19 plus 20, plus 1. Going to give you 20. We go back to the top. This here is going to be 20 now. Is 20 less than 20? The answer is false. So what do we do when the while loop is false? We come out of the loop. We exit the loop. So we have to ignore everything here and continue sequentially. So we jump to this step here. You are not a teenager. Did that help you? Great. Any other questions from anyone? All right. So we're looking at the repeat loop. Same basic example. Remember the condition is at the end. So let me zoom out back. All right, so we have 3 variables at the top here. We have repeat. We're going to prompt. So enter mark. So I'm going to enter 40 once again. We're going to store 40 into mark. Now, if mark is equal to -1, so this here is the loop. So I'm going to draw my line so that I can know where it is starting and where it is ending. So notice from the top here to the bottom here. It's basically repeat until. That's how you know the starting and that's how you know the ending. Repeat until. And one thing that always helps me is that it's repeat until it is true. That's how I usually remember it. Repeat until it is true. And if you can remember that, repeat until it is true, then you basically can reverse engineer and do the opposite for everything. As once you can remember it's repeat until it is true, then you know that it's false to exit, and then basically the while loop is the opposite. And that usually helped me to remember it. Remember the difference. All right, so we're at this line here. We input 40. We're at if is 40 equal to -1. False. So 40 is not equal to -1, so that's false. So remember this then keyword, we have to ignore it because our condition is false. So we carry out this else because the condition is false. So we say total plus mark, but notice at the top here, total is 0, but we enter the mark, so that's 0 plus 40. 40 is going to be stored in total, and we have our update. Count started off with 0, so that's 0 plus 1 and give us 1 there. Now we have our condition at the bottom here to know whether we should exit or enter. So it's going to say until mark is -1. Now, is 40 equal to -1? Because remember, mark we enter is -1. Is 40 equal to -1? False. It's not equal. So what do we do when the condition is false? With a repeat, we repeat the loop. So we go back to the top. At the top here, we're gonna enter 60. So input 60. Is 60 equal to -1? False once again. We ignore the true. We carry out the else. So let me take the time and go through here. Remember, total has 40. So that's going to be 40 plus 60. As we just enter 60 for mark. Total had 40 from before the previous loop. So that's 40 plus 60. That's going to give us 100. So count had 1 before, so that's going to be 1 plus 1, and that's going to give us 2. And we go back to the bottom here. Is 60 equal to -1? False once again. So we repeat once again. Now we're going to enter -1. Is -1 equal to -1? True. So, but remember, this is the if. So, we need to carry out this then statement, then display, end of mark. So that's going to be displayed on the screen. But this else, is going to be ignored because it's for this if here. So I can draw this line here to indicate this if section here. So this else is going to be ignored, and we're going to go to this condition at the bottom here. So we enter the -1 until -1 equals -1. So that's true. And what do we do when repeat is true? We exit. So because that condition there is true, we exit. So if we started with another if, and that's the else there, if count equals 0, does count equal 0? No. Count is 2. So does 2 equal to 0? False. So you have to ignore this here, and we have to go to this false part here. So we do our calculation of average. So we take our total is 100. We divide that by the count, which is 2. 100 divided by 2, we get 50 stored in average, and then we output 50. Have a look at it. Tell me if you have any questions. All right, no questions. Remember, you just got to remember that the for difference, that's how the loop is going to work. And you still got to work with sequential statements. You still got to work with the rule for the if, then, else. It's just following simple rules and remembering what are the rules. And you'll be fine. All right, so those were the indefinite loops. Now the for loop, the definite loop. We know for sure how many times we want the loop to run for. So this is the structure of the for loop. We have the keyword for, and we're going to have a variable. Now we need to indicate what is the starting value of that variable. So we can say start from 0, or let me say start from 1. Start from 1 to 10, final value, and then the keyword do. So that's the general structure. For variable starting value to whatever final value, do. Now, if you're going to go in the reverse order, say for instance 10, you're going to start from 10, you have to say down to 1. So you got to remember that difference there. If you're counting upwards, you got to say 2. If you're counting down, you got to say down to. All right, let's look at this. Let's look at this example here. So, but if you notice, there is no update. Notice we have the variable here for, well, that's the statement. The variable is count. And it's saying for the variable count, number, we're going to go from 1 to 2, do. But if you notice, there is no number equal number plus 1. Why? Because the for loop automatically updates. See, because it knows it is counting from 1 to 2. So you don't need to tell it to update. It knows it will update. It knows it has to update, basically. So it self-updates. So it still has that criteria or that part of being updated. So this here is going to start off with 1, because remember the starting value is this first number here. So start off with 1, do. We output, the number is 1. So if you notice, the results are at the bottom here. The number is 1. And then it goes back to the top. It increments. So this here is now going to be 2. Remember, it automatically updates by itself. So this here is going to be 2. And we can output the same line again. The number is 2. And then we come out to the loop. because it's going from 1 to 2. And that's simply how the for loop works. It self-updates, it self-tests itself. It knows that it has to run from this number to that number. So once it knows that it's starting at this value, ended there, it runs that, and then it just continues. It comes out of the loop and then continues sequentially. Let me just look at this final example of loops. So it's a combination of, there is a loop that has a combination. I think that's it. Let me look at the same one. So title at the top here, we have 2 initializing, sum equals 0, count equal 1. We have a repeat loop. I'm going to draw my line to indicate that this is the starting, this is the ending. Repeat until, remember once this is true. So if count is even, is count even? Count is 1. Is count even? False. It's not even. So I have to ignore this here because my condition is false. This here is outside. If you notice the indentation, this count here, this next step here is outside of this then. So that's what's indicating is not a part of the then. So you have to run this here. 1 plus 1 is going to give us 2. Repeat until count equal to or greater than 20. So is 2 greater than 20? False. And remember, we exit when it is true and we repeat when it is false. So because it's false, we have to go back to the top. And it's going to keep going like that back and forth until we do type in 20 and we get true and we exit. Any questions or comments? All right, so that's basically how all of the loops work. If no questions on any of those pseudocode, so basically from that chapter there, we looked at, what did we look at? We looked at a lot of statements that you need to remember. Where did you start the chapter? Yeah, we looked at some various statements that you need to remember. The conditional statements. Remember we have if then and if then else. Those are the 2 conditional statements. Then is always looking for true, else is always looking for false. If then, it never looks for false because there is no else. Sequential statements basically means you're running the steps one after each other. Loops basically mean you're repeating something, and we looked at all the differences in detail there. Nested basically means you put in something within another. Nested is not only for if statements, because you can put other statements within other statement. You can put a loop within another loop. So for instance, I could put a repeat loop within a while loop, and that's called a nested loop. So nested condition is referring to the nested if condition, but you can have nested loops also. Anything basically can be nested. All right, flowcharts. So flowcharts are algorithms that use symbols to depict input, processing, output of data and information. These symbols use the same terms to illustrate the flow of data. So it's basically the same thing you learn in pseudocode, but just that we use symbols to represent all of those keywords. So to indicate start and stop, so start and stop, we use the terminator symbol, which is basically an oval. To indicate input and output, a parallelogram. To indicate any calculation, we use a rectangle. For decision, for if, we use a diamond. We were talking about subroutines, separating the program, breaking it up into parts. So if we have like a part of a program we want to connect to another part of a program, we use what's called a connector. And we have what is called flow lines to indicate what's the direction of the data that it is flowing in. So basically everything that we learn is going to be applied, but just that we got to remember the symbols. The flowchart is technically much simpler because the lines basically show you just got to follow lines. So you start, you input 3 numbers, 10, 10, 10. You add those 3 numbers, you get 30. You output the result, 30, and you're done. That's simple. We have another one here. You start there. You input max temperature, min temperature. The max temperature is 40. The min temperature is 60. Calculate average. You add 40 and 60. You get 100 divided by 2, and you get 50. That's simple. But you just got to remember what the shape does, what it's telling you to do. But it usually has keywords inside of it also. If you notice, you can still use the keyword. But in the exam, they might not use it. So you got to remember what the symbol does. The same conditional statements that we learned about, if then and if then else, same rule applies. But notice, remember the diamond is used for that condition, decision, that condition, the if. What has happened? Yeah, so this is basically the if here. I think my computer's overheating now. Yeah. So we start at the top here. We input a mark. So say, for instance, we input 40. And let me see what I can close off. Yeah. So the question is mark greater than 40. So is 40 greater than equal to 80? The answer is false. So that's going to be no. And we basically just got to follow the line. That there is no, and we end the program. But if it is greater, say for instance it was 140, then if it is, then yes, so that's going to be true. We come out to the bottom here, we output excellent results, and then we output please see your teacher, and then we end there. So it's much simpler than the pseudocode. You just follow the lines and follow the instructions. But drawing one from scratch, that might be the difficulty, because remembering what each symbol does, that's going to be important. So notice here we have an example of the connector. So like this here, if, like say for instance, this was not here, that shape was not there, here actually had a connector symbol like that, it would have indicated that this was connecting to that. That's basically how it is used. To indicate one section of the flowchart can be used to connect another section of the flowchart. That's simple. Good. So the general structure for decision is that is going to have one line going in and 2 lines coming out. One is going to be true, one is going to be false. So it would usually be labeled true or false, yes or no, because there is no dedicated path to go out of. You would have to indicate which side is true, which side is false. And you can't use the bottom. Any one of the sides it can be used. So like this example here. So we start there, we input 3 numbers, a set of 10s. We get 30 there. Is 30 greater than 50? No. So we come down at the bottom here, print, the sum is less than 50, and then we end the program. If it was greater, say for instance 130, we print total, so we output 130, and then we end there. Any questions, comments so far? So how we know, let's see, not seeing. Okay, so this, which one? Okay, so this one here is going to be, let's see, that one is considering if it's false. No, let me not say that before I confuse you. All right. So nested condition, basically nesting the if, putting one within the other. So this is just a flow chart of that. Notice this one on the right hand side here. has multiple paths. So we start at the top here, we input a mark, we input 40, we come down here. Is 40 greater than or equal to 80? No. So we come across here. Is it greater than or equal to 70? No. Come across here. Output, please await the end of term reports. And we end. So remember, we follow the flow lines. If it was 60, 76, I do over 76. Is it greater than or equal to 76? 80? No. Is 76 greater than or equal to 70? Yes. So you come down here. You get satisfactory, and still please output, please await the end of term report. So different paths, it does just indicate a nested condition because you can take different condition one after the other. All right, so a loop, you can tell there is a loop once a line is going up back. So repeat a certain step to go back to a certain part of the program. So you won't see keywords like repeat or while, you may not, but once you see that line going back up, that's an indication. So you start, number got initialized with 1. So is 1 less than or equal to 3? That is true. But here we can tell whether if it's a repeat loop or a while loop because of where the condition is. So we started off with the condition, so we know it is a while loop because we start with the condition. So is it true? Then yes, we come down at the bottom here. We say 1 plus 1, so that's going to be 2 gets stored into number. We output number, which is 2, and we go back up to the top here. So then we get 2, and then we get 3. Eventually we're going to get 3. Eventually we're going to get 4. So is 4 less than or equal to 3? The answer is going to be false. And then we come out here and we exit the loop. So while loop, we exit when it is false. This one here is a repeat loop. As you can see, the test is at the bottom. So start, you enter the number 1. 1 plus 1, that's going to give us 2 at the top here. Remember, we're following the flow line. We output 2, and then we're going to run a test here. Is 2 equal to 3? False. And what do we do when the repeat loop is false? We run the loop again. So we go back to the top here and we run it again until the condition is true and we exit. Any questions? Any comments? Anything on flowchart? All right, let's look at this final example. So we start the flowchart. We initialize sum with 0. We initialize count with 1. Following the line, we go to the decision. Is count an even number? False. Where do we go when it is false? We come out to the side here. We meet up at this junction here and we come down. Count plus 1, what is count? Count is 1. 1 plus 1, that's going to give us 2. We come down again. Is count greater than 0? 6. Is 2 greater than 6? False. What do we do when it's false? We go back up. Here, we follow the line and we come down here. Is count an even number? Yes, because it is 2. So this now is going to be true. And then we come over here and we do sum, which is 0, plus count, which is 2. So that can be 2 inside of sum, and then we just keep going like that over and over, back and forth, until it actually ends. All right, so that's it for pseudocode flowcharts. Any questions before we move on? All right. Arithmetic relational logic operators. In many of the examples in this chapter, you have seen fragments of pseudocode such as age less than 20, number less than 3. These conditions are evaluated in the arithmetic and logic unit of the CPU. This is form 3 work. Remember, the part of the CPU that does all calculation, that is the ALU. Arithmetic operators, those are basically operators such as addition, subtraction, multiplication, division, and so on. So these are the signs for them that you have to use. Plus sign, minus sign, asterisk for multiplication, forward slash for division. Modulus is the percentage sign also, modulus. Modulus, it gives you the remainder of a result. So like for instance, if you do 3 divided by 3, or let me get another example. So if you do 5 divided by 3, then if you do division, this is basically your answer. But modulus is basically how much is the remainder, which is basically going to be 2.2, 2 remainder. So modulus is how much remainder. Division is basically, well, we all know what's division. How many times you can go into. A relational operator is basically comparing. So we already know what is equal to, more than, less than, equal to. Note this is not equal to, the 2 arrows pointing away from each other. So they're called relational operators because you're comparing 2 values. You're saying whether something is greater than, equal to, whatever the case may be. Logic operators. Logic operators, this is a bit more technical. Let me see, I think there's a summary table of it somewhere. All right, let me just go through it one by one. So logic deals with, it's a bit of like comparing. The easiest of the logic operator is the not operator. What that basically does, it gives you the opposite of the value. So if something is true, it's going to make it false. So like we use what is called a truth table. So if the day is not Sunday, if the day is not equal to Sunday, so they're not equal to, let me see, the result is the option. The not is basically the opposite. That's just basically it. So, like they're basically saying here that if it is equal to Sunday, the opposite then is basically not equal to Sunday. The opposite value, as I said. So, like the opposite of true is false. So, if it is equal to Sunday, not if you carry out the not operator on this here, then it's going to be what is not equal to Sunday, which is any other day. Monday, Tuesday, Wednesday, Thursday, Friday, and so on. The AND operator, this is basically what we, similar to what we would have covered in database. When you're running a criteria, you're running a query, and you use that AND operator, and both questions have to be true at the same time in order for the result to be true. So like in this case here, notice the AND operator here. So if Mark is greater than 70, so it has to be greater than 70, and at the same time, he has to be in term 3 in order for this to be true. If any one of this is false, say for instance, the term was the term was 2, then we would not have carried out this true here because the condition would have been false. So in an AND operator, both have to be true at the same time. This is what we call a truth table. This usually helps us to remember. In an AND truth table, both condition have to be true, or all the condition have to be true in order for the output to be true. Any other combination is going to be false. You just got to remember this here. Both have to be true for the condition to be true. Anything else is false. And this is an example of how it might be used. Once again, you have the same if operator, and we're running the tests to know if we should carry out the next step. We're going to carry it out if it is true. But in order for it to be true, both of the conditions at the top here have to be true because we are using this AND operator at the top here. Both have to be true at the same time. It has to be greater than 70 and it has to be term true at the same time. The OR operator, the same thing that we learned about in database, the OR, either question can be true and the output is true. So if you notice, obviously if both are true, you're going to get true. But once one of them is true, notice here, once at least one is true, you're going to get a true output. That is going to be true, that's going to be true. So if both are false, you won't get a false. You won't get a true, so it's going to be false. Let me see. Good, so like this here. So if the mark is greater than 70, so say for instance, this here was 60, so that's going to be false. But the rank is 6, and this here is true. So we're going to still carry out this then here because at least one of it was true. So you just got to remember this truth table here. The way I remember it is that for the AND, all true give you true. Everything else is false. Any other combination is false. For the OR, all false give you false. Basically opposite. All false give you false. Any other combination gives you a true. So going back to this example here, if we're running this condition, this test here, to know whether we should carry out this then statement. And we only carry out this then statement if the condition is true. So how do we know if the condition is true? Is mark greater than 70? False. So that's already false over there. But on the right hand side, rank, which is 6, is less than 10. But that is true. And based on the table, once at least one of them is true, the final output is true. So we will carry out this final step here, this then statement. If both were false, say for instance that was 16, then this here would be false. And then the complete output is false, then we ignore this here. It's a bit technical, very technical, but it's basically like a comparison as to the two values. And once again, like I said, the NOT is basically the opposite. NOT is when you have two options. As the example says, you have true and false, you have yes and no. So if you have the word yes and you apply the NOT operator to it, it's going to turn to no. If you have the word true and you apply the NOT operator, it's going to turn false. Yeah, that's basically it for the NOT operator. So where's the truth table? Oh, the truth table is right here. I was looking at it earlier, but so notice if it is true, and once you apply the NOT operator, it's going to turn false. And if it was originally false, and you apply the NOT operator, it's going to turn to true. It's basically turning it to the opposite value. 0 is going to be turned to 1. 1 is going to be turned to 0. Note that true is representation of 1, just in case you need to remember that. And false is a representation of 0. 1 is also on, and 0 is also off. Just a side note in case you need to know. Any questions, any comments? All right, so we can look at this one here. So notice a combination of ands, the and operator. So if Mark is greater than 70, so say for instance we put 60 here, and at the same time he has to be in term 3, and at the same time he has to have a rank less than 10. But notice I put a mark of 60, so this is false here, true, and true. So will we carry out the then? No, because one of this here is false. Everything has to be true in the then. The or here, all right, it's basically the same thing we looked at before. All right, so testing your algorithm now. So you finished designing your algorithm. How do we test our algorithm? So desk checking is the process of reviewing an algorithm for the correct processing and output. So after you're finished creating your algorithm, you don't just go and convert it into a program. The next step is to test it. You test it manually. That's called a desk checking process. You do this manually by manually executing the steps in the algorithm one by one while keeping track of the results. We started desk checking with example 12 by going through each loop and explaining the output. The logic of your algorithm is an important part of testing. Using a trace table will help you test and verify your algorithm. So desk checking is the process of testing it, but you use what is called a trace table to carry out this desk checking. An algorithm is a sequence of steps which seek to solve a problem. If you freeze the algorithm at any point, then you can have a snapshot of the state of the variable at that point. So I saw a paper with this question here, similar to what is being mentioned here. Basically, what you need to understand is that it's the same thing what we've been doing when we were going through all of those loops. Like for instance, when we were going through this loop here, if you were to stop this loop at a certain point, if you were to freeze it at a certain point, like how you're seeing it right now, then the variables will contain certain values. That is the purpose of the trace table, for you to manually document all of those values. And in the exam, they could show you an algorithm, they could show you a trace table, something, and they could ask you what will the value be when it freezes maybe at the second loop or some form of manner. Or they might even ask you to carry out, create a trace table. So the trace table is a very useful tool which allows you to see the state of your algorithm with as much detail as you wish. Each row of the table shows the state of the one step in the algorithm, and each column shows the value of the variable. The trace table allows you to check the algorithm for errors. So why do we use a trace table? To check the algorithm for errors. So instead of going to convert into the program and then you run into error, you test it with the algorithm first. So here we have an algorithm. So, and then we're gonna look at the trace table. So we're gonna read or input a value into quantity. We have a for loop. The variable sold equal, we're gonna start off with 1, and whatever value we enter into quantity, do. So this is x, and basically we carry out that calculation there. So what happened here, this is our trace table here. So notice in the column is where you're going to find your variables. So step number 1 here, notice quantity here. Step number 2, notice sold. Step number 3, notice invoice. Step number 4, notice value. So that's how we usually put them. It's 4 major steps. So we basically have 4 major columns here with the value from each step. 4 was already placed straight down because we're going to enter, they're entering the value 4 here. So it's going to keep that value of 4. There's nothing replacing that value inside of quantity here. So that's why it's going to keep this 4. That's why this 4 is repeating here. So the purpose of the trace table is to trace the values of the variable as it changes throughout the algorithm. So let's continue. All right, so let's actually go through this here. So read 4. So notice the entered 4. We're going to loop 1 to 4. So it's going to be 4 minus sold. What's sold? So 4 minus 1. So that's going to be 3. 3 is going to get stored in invoice. 5 times 3. 5 times 3 minus sold, which is 1. What is that going to give us? 5 times 3 minus 1. That's going to give us 14. Is that correct? Yeah. And we end there and we repeat the loop. So notice in this here now, sold is the variable. So that's why it's counting 1, 2, 3, 4, because it will increment. Sold is the variable at step number 2 that is being used for updating the loop. And remember, the for loop automatically updates from 1 to 4. So it will increase 1, 2, 3, 4. So that's why here, at the first loop is going to be 1, the second loop is going to be 2, the third loop is going to be 3, and the fourth loop is going to be 4. So that's why this is going 1, 2, 3, 4. And remember, this is staying at 4 because we entered 4 at the beginning. Nothing's going to change it. All right. So remember, we went through the first step there and we got 3 and 14. So the 3 here from I and V and the 14 here. So notice that was placed into the table here. 3 and 14. If we go through it again, we can notice we can get 2 and 8. So let me go through it again. And we're going to get 2 and 8. So sold, we're going to repeat the loop. Sold is now going to become 2 because remember it's going to update. We're running the loop for the second time. So 4 minus 2. 4 minus 2. That's going to give us 2 out here instead of 3 from before. So that's 2 there. 5 times 2 minus 2 because sold is now 2. So 5 times 2 minus 2 and we get 8. So notice 2 and 8. And if we look at the table, notice I have 2 and 8. So 2 was stored inside of INV and 8 inside of VAL. So let me continue to gain and see if we can get the next value. So this 2 here is going to update to 3. And so here, that 2 there is also going to update to 3. So it's going to be 4 minus 3. This is going to give us a value of 1. And it's going to be INV, which is 1, minus 3, which is sold. So that's going to be 5 times 1 minus 3. That's going to be 2. So that's going to be 1 and 2. So let's just keep those values at the side. And let me go through it again so we get the final row. This here is going to be updated to 4 now. This here is also going to be updated to 4. 4 minus 4, that's going to give us 0 out here. And I and V is 0. This 3 is going to be updated to 4. So that's going to be 5 times 0 minus 4. That's going to give us negative 4. Nothing's wrong if you get a negative value. Just remember, you're just tracing how it is carrying out this calculation. So the third line is going to be 1 and 2, and the fourth line is 0 and negative 4. So notice 1 and 2, and the last line, 0 and negative 4. So the trace table, it's something very simple. It's basically what we've been doing all the time, going through the algorithm, step by step, tracing how the variables change throughout the algorithm. But the table now, the trace table, is you actually just documenting it. So the reason why we have 4 rows is because the loop repeated 4 times. The headings are the variables that occurred, that appeared at each step, because that is what we trace. We trace variables. We trace how they change throughout the algorithm. And you simply just have to document how the variable changes its values throughout the algorithm. Any questions? All right, so we finished that entirety there of basically algorithms, pseudocode, and designing, testing, and so on. The next chapters is basically now getting into developing the program. So do you guys want us to stop here, or you want us to continue? We could finish it in half an hour, less than half an hour. So if you want, we can go for another half an hour, finish off this here, and then end. Let me know what you guys want to do. Continue or stop here? Okay, we can go for another half an hour and finish off all of these blue chapters. All right, so program implementation, programming languages. So chapter 9 introduced the concept of problem solving by writing algorithms, drawing flowcharts. It is during the implementation phase that an algorithm must be converted into programming language or programming language statement called source code. So this term here is source code. This refers to when you're typing the programming language. So if you actually look at the actual typing of a program, this here where you actually see it on the screen there, that's what you call the source code. So typing of that programming language is called the source code. Those statements. In this chapter, we share some examples of programming language to introduce the process of writing short program. So the implementation phase is the first step. We already covered this. You translate that algorithm you created into a program language of your choice. If you notice, you can translate it into any language. That is why we were given all of those rules and guidelines. Because when you create the algorithm, it's not just for one programming language, it's for any programming language. It's for any person to be able to read it. So if you have a correct and precise algorithm, the translation should be almost, line by line. So that is why the guideline also said each algorithm step must be one logical step so that you can basically now translate it line by line into your program. Locate and correct any errors in the code. So these are the two types of errors that you need to remember. Syntax error, which are errors resulting from incorrect use of programming language syntax or violation of syntax rules. What are syntaxes? Syntaxes are basically the rules as to what you have to follow when you are writing the programming language. That's like when you're writing a sentence in English, when you were doing your English exam. You have to write your sentence in a particular format, subject and verb agreement, and all the rules and vocabulary and grammar and so on. And if you violate any one of those rules, you can have a deduction in mark. Similarly, if you violate the structure of the programming language, it's not going to work. And violating that structure is called a syntax error. A logic error is made by the programmer, such as those made by using wrong signs and arithmetic operator. So if you, a logic error is when you do a wrong calculation. So the syntax is correct. You did A plus B, that is correct. But technically you were supposed to do A plus C. So it's an error on your part. The calculation was done wrong. Which in the syntax is correct because A plus B is going to work. But does that, it gave you the wrong answer. That is called a logic error. I'm not sure if this is going to be mentioned at any point in time. We have an error called the runtime error. A runtime error occurs, as the name implies, when the program is running. The syntax error usually occurs before you run the program. Because when you before you actually run a program, you have to do what is called compiling a program. So all this is important to remember. Before you run a program, you have to compile that program. Compiling is converting it into the program you can see, converting it so that the program can work. So while doing that conversion, it is going to run through all the codes to make sure everything is correct. And while running through, that's how it's going to come across some of these errors, the syntax error. So while compiling, while checking, it's going to come across if you have any syntax error. The runtime error, as I said, is when when you run the program, that's when it's going to, like maybe while running, you enter a wrong value. Like instead of entering a number, you enter a letter. So that basically stops the program. Something stops it while it is running. That's called a runtime error. Now, when you're going to notice a logic error is that like while running the program, you notice you're getting a wrong value all the time, a wrong calculation all the time. So that's when you might notice the logic error. But in most cases, the logic error are very hard to detect because you wrote the syntax correct, but does that it's giving you this wrong calculation and you might not figure out why you're getting this wrong calculation. Execute the program code. So after you finish converting, you execute the program code. This includes testing data, using test data to ensure the program is working as expected and can produce error message as needed. Now this is test data. Why do we test the program? We use what is called a test data. Why do we use test data? Why can't we just type in random values? The reason why we use test data is so that we can create certain scenarios. So we know that if we enter A, the program is going to crash because it's only supposed to accept numbers. If we enter 1, the program is going to work. Those are examples of test data. So you're testing it with different types of input to know what is going to work, what is not going to work, and to know if it is working as expected. Because you know if you enter A, the program should not work. But what if for some reason while entering the A, it does work? Now you got to go and figure out why it is working when it's not supposed to be working. That's the purpose of test data. To test it with a certain variety of data to test to see what is working, what is not working, what is supposed to be working, and what is not supposed to be working. Maintaining the program. This includes documenting the program throughout the coding process by writing comments on how to use the program, as well as comments within the program and so on. So documentation, like if anybody's going to use the program, they can read the documentation and have a guide as to what each line does. Maybe it might not be each line, but certain parts of the program, how it works, what it does, and things like that. Choosing a programming language. Programming is the art of writing the solution to a problem by using a language that a computer interprets. A programmer actually instructs the computer how to solve a problem since it cannot come up with a solution to a problem itself. A computer program is a set of instructions that tells the computer what to do and how to do it. These instructions usually converted into a sequence of numeric codes called machine code, which is stored in memory. So when you translate into the programming language, as I said before, you have to compile it. When you compile, it is being converted into what is called machine code. That machine code is going to be transferred into the memory of the computer, where the computer is now going to process that program. The CPU interprets the code to carry out the instructions of that program. First, you select the type of language that is suitable for your task. There are many programming languages that can be used to write programs or create any kind of software. These languages can be grouped into two categories. You have the low-level language and we have the high-level language. Low-level languages, these languages are machine-dependent. Machine meaning the computer. That is, the code written can only be understood by a particular computer or processor that was used to write the code. Machine language uses digits, binary digits, that make up the binary code. So machine code, also called low-level code, low-level language, it basically refers to binary. And remember, your computer only reads and understands binary. Even though we're seeing all of this graphical aspect here, to the computer, it is simply binary. That's all it's seeing. All right, we're not going to go through that. You could run through it quickly. Advantage, code runs very fast and efficiently because the computer will be able to understand it directly. There is no conversion. So basically when we write our programs are in high-level language and it has to be converted into this binary language. So if a program is already in binary, it's going to run much faster because the computer directly understands it. The disadvantage, you would not be able to understand it, so it's going to be hard for you to actually program something in binary. Now, after the lower level language of creating programs in binary, we came up with assembly language. Now, assembly language has the same structure and command as machine language, but allows programmers to use abbreviated words called mnemonics instead of binary. So instead of writing this binary code in the machine language to program something, the equivalent assembly language code may be add A and B. So the assembly language uses abbreviated mnemonics, which simply means add the contents of A and B. Advantage, you can easily convert the machine code by a program called an assembler. So notice this keyword here, assembler. Assembler is what you use to convert the assembly language to machine language. Disadvantage, it was still difficult to understand. That is why today we use high-level language. What is the high-level language? High-level languages are different from low-level language in that they are not machine-dependent. You can use it on any computer, even on your phone. Therefore, programs written on one computer can generally be used on another similar computer. They also use keywords similar to English and are easier to write. That's why everyone uses them today. These languages are designed to be easier for you to understand. They are converted to machine code. So if you notice, everything has to be converted to binary in order for it to work, rather than translating one language to another, so that the computer can carry out the instruction in the CPU. Advantage, It uses English words, so it's easier for us to create. Disadvantage, we got to convert it to machine language, and that can take time, processing power, and so on. Pascal was created in the 17th century by Blaise Pascal, a language that uses structural programming. It's mostly used for teaching, and so on. It's an alternative to BASIC. Visual Basic, it was developed by Microsoft. It derived from BASIC, but it gives you more of a graphical user interface in order for you to create programs. All right, the next chapter, if no questions. Okay, don't need to read that. What do you need to create a program? Well, a simple text editor can work, but we have softwares that are dedicated for certain particular languages that can be used also, but a simple text editor can be used, like Notepad and so on, Notepad++ and so on. Programming languages, different programming languages is going to have different syntaxes and different semantics. What is a syntax? A syntax is the precise way in which the statements in a program must be written in order for it to be understood. So that's how you get syntax error. If you don't write a statement correctly, you're going to get a syntax error. There's a set of rules for combining the various elements that make up a programming language. The syntax allows the programmer to create a correctly structured statement that is legal, although it does not guarantee that a statement will be useful. Even though you might type all the statements correctly in the correct order, it doesn't mean that it will work. Semantics. Semantics is the meaning associated with words, symbols, and punctuation. Like for instance, in Pascal, if you use a period, that indicates the end of something, the end of the program. In which program? The programming language, if you use a semicolon, that indicates the end of a line. So that is called semantics, when certain words, symbols, punctuation have certain meaning. Even like the asterisk, there has a meaning of multiplication. So in Pascal, semicolon represents the end of a statement. So that was Pascal I was talking about. Yeah, so that's the difference between semantics and syntax. All right, so your program structure is going to be similar to your algorithm. You're going to have statements to establish the start of the program, just like how your algorithm had a start. It can include program header, comments, like who is the author, when you created it, and other comments. After that, you're going to have your declaration and your initialization. But your initialization is going to come after your declaration. So in the declaration, you're going to declare what are your variables, what are your data types, and after that, you can do your initializing. Then you're going to have the body of your program. So this is where you're going to have all your statements, your if statement, your loops, and everything. And then you're going to have something indicating the end of the program. Okay, so this is an example of a Pascal program. We have the keyword program. That's to indicate the start of the program. There we have a title here. The curly brackets are used to indicate a comment. So whatever is in this comment, it won't be a part of the program code. It won't be run as part of the program. It's just there as a guide. Begin indicating the starting of statements. And here we have a keyword indicating you're going to be putting something on the screen. You won't really be tested. I can't guarantee that. But because I I think I have seen them put Pascal in the exam, but usually they're not supposed to because of the variety of programming languages, and they don't tell you to learn a particular programming language. But you guys have created a program, so you should have a relatively reasonable idea. But I was going to go through this simple example here. Once again, we have program title and the title of the program keyword, title. var is indicating the declaration. So the variable age is being declared with this colon here with the data type integer. Cost is being declared to real, class is being declared to char. Notice the semicolon to indicate the end of the line. Even the title has a semicolon. Begin to indicate the start of the statements. Notice the initializing is here. Initializing with a colon and equal sign. Variable, and it's equal to what value. In Pascal, write is to indicate something being put on the screen, and read is to indicate you are accepting data. The ln is to indicate that you're putting the cursor on the next line. If you do not do that, it keeps the cursor on the same line. All right, conditional statements. So program, keyword, title once again, var, declaration, begin, initializing. If form is equal to 3, the same rules as before. If the condition is true, we carry out this here. If the condition is false, we carry out this here. It's basically the same thing we would have learned so far. And notice this here is indicating the end of that program. End with that period there. Loop. Okay, so while loop. Notice the test is at the beginning here for the while loop. We have a variable starting off there, initialized with 0. And notice we have begin and end here indicated that this is the start of the while loop. This is the end of the while loop. Excuse me. And this is our update here. So notice they're not using count, they're using line. And they're using line as that variable. So like I said, they could use different variable names. So 0 plus 1, and they continue like that and so on. Over here we have the for loop. So program keyword, title for loop. We have our declaration here, line as integer. We begin for loop. For the variable, start off with 1, go to 10, and then repeat this to 10 times. All right, running the program. So usually you will go through several steps before you can type your program instruction, let alone view output from your program. At this stage, you are ready to see your program run. After you have typed your program using an editor, it is called source code. So this here is called source code. So you're typing that in the text editor. Next, it needs to be tested for correctness. To do so, the source code must be translated into machine language called object code. So after you finish translating, it is called object code, so that the CPU can carry out the program instruction. From source code to object code. Converting a program from source code to object code is performed by a translator. This is a system software. If you guys can remember from third form, we have two types of software, system software. And under system software, we have operating system and utility software. So translator is a system software, like how we have Windows as operating system and so on. A translator is a system software. It is used for translating that source code to object code. Sometimes a program listing is shown, which is a printout or a soft copy of a source program instruction as a reference while working with and coding the program. These are programs that translate a specific program from one language to another, from high-level language to low-level language. Interpreters, compilers, assemblers. Those are our three translators. Interpreters, compilers, assemblers. An interpreter translates the source program line by line. So line by line, we mean line by line, literal line by line. It translates that line, then goes to this line and translates it. But when we say line by line, it translates it and it tests it and runs it. That's what we mean. So it translates this here, tests it and runs it. Translate this next one, test and run. Translate, test and run. Translate, test and run. And continues like that. An interpreter translates the source program line by line, and if any error is detected, then translation is aborted. So that's the disadvantage with the interpreter. Like if it has 10 steps and step number 3 has an error, it's going to stop at step number 3 and stop translating. If no errors are detected, then the interpreter instructs the control unit to execute the translated instruction. So basically, if it detects no error, it runs the program. This cycle will be repeated for every instruction in the program. This is an easy but inefficient way of executing or running program not written in machine code. BASIC is a language which is interpreted, or basically BASIC uses the interpreter. So a block diagram of demonstrating that, you have a source code, it gets interpreted. If you run into any error, you have to go back to the source code and fix it. Otherwise, if no error, the program gets run. Compiler. A compiler translates all program instructions at one time. So it takes all of the steps, all the entire source code, and makes one large translation, and produces a standalone object program that can be executed and run on its own. Error checks for syntax and logic errors are performed, and an error summary is issued. So remember I said earlier, while compiling, that's when it's going to check for those syntax errors and logic errors and so on. Once the program is compiled and no errors are detected, the compiler will then instruct the control unit to execute the program. So once no error, you run the program. If the program produces incorrect output or stops unexpectedly, then another type of error may be caused. Otherwise, the object program will be executed each time it is run, but the source code only needs to be compiled once. So once you compile it one time, you can run it how many times you wish. If there is any modification to the source code, then is when you're going to need to recompile the source code. So COBOL uses the compiler. So step number 1, you have your source code, you compile it. If you get any error, you're going to basically go back here and check back your source code and compile. If there is no error, you get converted to object code. And if it does get converted, it executes the object code to obtain results. So notice you have runtime error here. So while running that code, while executing that program, if you do get error, which is called the runtime error, while the program is running, then you got to go back to your source code and try to figure it out. Otherwise, if you don't, you get a working program. So those are the 3 types of errors there. Programming error. Often when a computer is compiling or interpreting your source code, an error, whether minor or major, will cause it to either output wrong results or not reach the stage of output at all. These are different types of error which will cause your program to crash. So syntax error occurs when a mistake is made in the language rule or sentence structure of the programming language. So we covered that already. Example of syntax error including misspelling of a variable or keyword. Syntax error stop the program instruction or source code being converted to machine code. Tools used with the program usually detect syntax error quite easily. So incorrect syntax since an operator. Okay, so here It requires an operator. You need to have a test. So you need to say whether it's less than 42, whether it's greater than 42. So not having that syntax, that rule of having an operator is going to give you a syntax error. Spelling error in begin. So we didn't spell begin correctly. That's another example of a syntax error. Logic error occur when a programmer makes mistakes in the sequence of the program sentences, such as wrong mathematical formula, wrong operator and expression, incorrect use of looping structure. Basically, you did something wrong. The program will usually compile. So this might be a question. So will the program work with a syntax error? The answer is no. Will the program work if you have a logic error? The answer is yes. Because the logic error does not stop the program from compiling. Because it's just a mathematical mistake, some mistake that's going to give you a wrong result. So it's not going to stop the program. So the program will usually compile. That is, the compiler will convert from source code to object code. Compilation with logic error does not generate any syntax error or warning message. But the program is run, when the program is run, it produces wrong results. So that's all you get from a logic error, wrong results. So the segment of code, a page, when less than 10. However, the programmer intended it to be greater than 10. So this is an example of logic error. Instead of typing more than, the person typed less than. Debugging. Debugging is the process of finding errors in the source code, understanding why they occurred, that's called diagnosis, and correcting them. Errors are often found through error messages generated by the program or the operating system, or because the program does not behave as expected. So how do you get error message? The program will either pop up error message, or you will notice that the program is not working as intended. Executing the program. If you have translated your program to object code without errors, you can now execute it and see the results. The two final terms commonly used with program execution are program loading, copying a program from hard disk to the memory in order to put the program in a ready-to-run state. That's called program loading from hard disk to the memory of the computer so that it can run. Linking. Combining various pieces of code and data together to form a single executable object code that can be loaded into memory. Linking can be done at compile time, at load time, also at runtime. Combining various pieces of code and data together to form a single. So this can be like the subroutines, merging pieces of programs together so that you can have one large program. So once your program compiles, you may either see your result on the screen or you may see another type of error. Runtime errors occur as the program compiles or runs. These errors are usually due to unexpected events such as division by 0. So the program, you cannot divide by 0 because if you do that, you're going to get error. So when a program, that happens in the program, you get a runtime error. If the computer runs out of memory, like physical memory, we're talking about the RAM here, like how my computer is almost running out of memory here, that can lead to a runtime error because it doesn't have space to store more data to carry out the program. Runtime errors can be very difficult to trace as the program may produce results most of the time. So what I was basically saying is that sometimes it might work, sometimes it might not work. So it's kind of like how sometimes some devices, they might work sometime, might not work sometime. And we're trying to figure out what's causing the issue. That's called a runtime error. So we can't really pinpoint what's causing this mistake. All right, so testing and debugging are necessary stages in the development cycle, and they are best incorporated early. Testing begins when you start to plan the program and continues until the program is completed and put into daily use. It is used to ensure that a computer application program is completed and does what it is meant to do. Testing attempts to find problems in your code. Debugging isolates and fixes the problem. Typically, when you test and debug your program, you need to ensure it runs without crashing, generating error message, and that the end user may be able to resolve. It should carry out reasonable action, produces error messages for a range of scenarios. So your program should produce error messages if an error does occur, so that the person know what actually happened. Helps the user to continue or restart the program if an unexpected user or system error occurs. So like if the system crashes or a program crashes, there should be some sort of option to restart the program, restart the system, or so on. Errors can occur at any stage of the software application. They may happen frequently if you make errors while using the application, for example, but they also occur as a result of problems such as power failures. So if you lose power just like that, it can cause issues with certain application because remember the application is working in memory, it's working in RAM, so it has to be stored permanently. When you close an application, it's actually going to take all of the data out of RAM and now store it inside of your main storage, your hard drive. So if it doesn't get to do that correctly in the correct manner, it can cause corruption to the data and it can cause corruption to the program. So if your computer experiences power failure a lot, it could cause damage to the software and hardware. Testing cannot prove that your program is fully correct because you don't always find all the problems right away. It can certainly detect bugs in the program, but there's no way to be sure that there are absolutely no errors in the logic of the program code. Therefore, the earlier a defect is found, the easier it is to fix. Testing a program involves creating a set of test cases. So remember, I talked about test data. You have correct values and wrong values to test to see if it is working, if it is not working, if it is working as it should, if it is not working as it should, and so on. Running the program with each test case and then checking the performance of the software. Test cases. A test case documents the values that are input and compares the predicted results with the actual results when a program is executed. So, like for instance, if you put in 1 + 1, then you're expecting 2. So, those are examples of test data and test cases. You put in actual values, and what you're expecting out of it is what you should be getting. And if you don't get that, you'll have to just figure out why you're not getting that. So basically your test data, so when choosing test cases, you must consider a range of values. So as I said, wrong values, good values, and so on. It is important to ensure every conditional branch, loop, and statement of the program is actually tested. So when you're testing, you test all parts of the program. Black box testing is used to check that the output of a module is as expected given certain inputs. The term black box is used because the actual code is being executed is not examined. The black box test provides no information about whether all statements or loops of the test module are necessary or not. So this is an example of black box testing, this diagram here. So we don't care about what is inside of the program. We don't care what loop is inside of it, what conditional statements inside of it in black box testing. We don't care about those things. All we care about is that if I type in 1 + 1, I should get 2. That's all we care about. Whatever value we type in, we should get the correct value, the correct output. White box test cases are designed to examine the inner structure of the program and are one of the most important test methods. The test checks the accuracy of the module from input through every possible path of the test object to the output. So it tests everything inside, all of the loops, all of the conditions, all of the processes, and so on. So I'm guessing black box because you cannot see inside, and white box because you can't see inside. Maybe that's why they name it that way. Since testing every value is impractical, you should choose a range of values to check specific error conditions. So you should also be aware of which test data, if any, would be expected to produce error. So like I said before, you should know that if you type in an A in a calculator, that should give you error. So that should give you an idea as to what test data you would use. All right, just a few more pages and then we'll wrap up. All right, so these are some examples of test data. So like if your program expects strings, which are characters, combination of character, you can test putting in empty string. Strings consisting solely of white space. White space is space. Like when you press the space bar. Strings leading or trailing with white space. So like if you type a space before a word, a space after a word, typing in special characters, foreign characters, like different symbols, different characters from different languages, those can be used for test data. For numbers, you can type in no number, you can type in 0, positive and negative numbers, numbers outside of the range, like if you have a range from 1 to 100, type in 1,000 and see what's going to happen. Those are examples of test data. So consider the program that gives the user access based on the correct username and password entered into the login screen. Examples of username and password as test cases can include combination of these values here. So if the person type in those values, you test and see if it's going to work or not. Testing has to be planned. Some of the sections of the program often have to be tested before their completion, and this often includes testing of other subroutines with which they interact. The results of the tests determine the quality of the application. Although quality varies from system to system, some common attributes include it must be reliable. This is the probability that the inputs to and use of the software will not cause it to crash for a specified time. So you make your program reliable in that it should be able to accept a range of input and it does not crash. Stability. A system software is stable or robust if an error message in its operation does not result in irreversible damage in the application. So you get an error, but the program, you could restart it and the program could continue to work and so on. Maintainability. This means how easy it is to debug, modify, and expand. So how easy it is to make changes. Usability. The system software should allow flexible input by the user. The result output should also be clear, well instructed, easy to interpret, error messages, and so on. So usability in that, like once again, if it's a calculator, it should only accept numbers, but if I type in a letter, I should be able to get an error message and say, look, I'm a calculator, don't type in any letters. Portability. This is the ease with which software system designed for one computer can be adapted to run on different computers. So you don't just build it for one system. I think this is the last chapter. Documentation. Documentation is an important part of software design process. Several types are produced during the process. Documenting programming code. Documenting your code means typing short phrases or comments describing what your code is doing. Comments placed along your programming code are useful if the program needs to be debugged or updated. If you write your code for your SBA and then review it a month later, you can spend some time trying to remember what some sections were supposed to achieve. Comments therefore help you and others to understand the purpose of your code, especially since your teacher or motivator will be reviewing it. Many students write their comments after the program is finished working. If you leave the comments for later, you may not remember why you used a certain method, use different variables, or use another set of code that doesn't resemble the requirements. Then you may resort to typing a comment that is similar to the code. This is not a good method. Commenting in programming code should include the following: an overview of the process or tasks rather than rephrasing each step. So basically just a general overview as to what the step is doing. You put the name of the author, contact information, the date that it was created or modified. This can give us an idea like when it was last updated or when it was created. If you have finally found a solution to a part of the code that did not work, you should document what you did and include any comments that would explain the section of that code. Adding comments to your programming code may seem like a tedious process. However, if you add them while you're writing your code, you may find that explaining the section will help you understand more about programming. So in BASIC, a comment seems to be in these asterisks. In Pascal, the comments are within curly brackets. And in Visual Basics, they use tilde. That's tilde? No, not tilde. That's apostrophe. User documentation. User documentation is concerned with what the program does and how the end user makes the program do what it's supposed to do. So basically, you're telling persons what the program is going to be used for and how they can use the program. It is usually the first contact they have with the system. It may give details of how to input data, how to format outputs, use the printer, save files, and so on, how to access features of the program, how to interpret system messages. So user documentation is like basically how you use the program, how to use it properly. User documentation should be structured in such a way it is not necessary to read it all before starting to use the application. It is usually integrated as part of the online help with lots of blogs and online chat rooms to share information on how to troubleshoot and use the system more efficiently. 5 common components of user documentation: a system overview, which explains what the system can and cannot do; installation documentation, which explains how to install the system and tailor it for a particular configuration. The document suggests how to recover from errors, basic problems, when things go wrong, illustrations, examples, and so on. An introductory manual, which explains in simple terms how to get started with the system. A reference manual, which describes in detail system facilities available to the user and how to use these facilities can be used. This manual assumes that the reader is familiar with the system and understands the concept and terminologies. An optional administrator guide, which explains how to react to situations which arise while the system is in use. It also carries out system housekeeping tasks such as making a system backup and so on. So different documentation for different purposes, how to use the system, when you get error, how to handle that error, and different types of errors and so on. All right, good. That's basically it. Any questions before we close? No questions? I guess that's it for tonight. Until next time.